Hello everyone, welcome to our next session on replica sets. Before starting with the replica set, in the previous session we have understood what is deployment controller and how the deployment controller works. So we got to know that we will get three powerful features of Kubernetes, that is scaling, rolling updates and rollbacks. So these powerful features we will get only if you deploy your pods, deploy your application via the deployment controller. Now in this session, we'll try to understand more about the replica sets. If you want to get the idea on the replica set, please do watch this video till the end. So now what is replica set and what is the difference between this replica set and the deployment controller? So replica set is also a controller like deployment controller, but replica set controller is managed by the deployment controller. I'll just quickly show the YAML file. So we created the deployment controller, when you are deploying your application with this application, when you are deploying via the deployment controller, so you will be having the replicas also. So this replica set is also a controller. This replica set is managed by deployment controller. So now what is the meaning of this replica set? How many replicas? Here we mentioned the replicas are 4. So why we need to mention these replicas are 4? When you mention 4 replicas, that means the Kubernetes will create 4 copies of pod. The 4 copies of pod means it will create 4 containers of this image. So which image you are deploying here to the Kubernetes? So this is the image, angular image point to you are deploying. This image will be created as a controller, and that created as a container, and that container will be having the pod. We have already understood that. So whenever you are deploying your application, say for example, so this is your application container and this is a container, and that will be wrapped on top of the pod. When you wrap up the pod is, so on top of the container we created a pod. So and this pod count is 1, right? So when you say the replica set in the application, in the YAML file you mentioned the replica sets are 4. That means what Kubernetes will create, like this pod, it will create 4 pods. So that is why we are mentioning the replica sets. So this will be pod, and this is also same pod and same container, and this is also same pod and same container. So that means the count is 4. So it's created 4 copies of the container. On top of that, it is wrapped as a pod, and this all 4 replica sets are present inside the deployment. So we are inside the deployment means here YAML file we mentioned as a deployment, right? So all 4 replica sets, all 4 copies of the pod, it's present under in one replica set. This is one replica set. And so what is this? This is a deployment. So inside a deployment, we have one replica set. Inside the one replica set, we have the 4 pods, 4 copies. So why we require these 4 pods? So that means whenever application, a real-time application, if you consider, and there are huge number of requests are coming to this deployment or this application. So request will be going to the different pod containers. So it's kind of a load balancing. So it will be all the request, instead of sending request to one pod, it will send to the multiple pods. So what this replica set it will do, it will manage as the count. Say for example, in the replica set, what you mentioned, the replica set 4. So that means whatever the desired state you mentioned the 4 replica set. So your Kubernetes replica set, it will maintain the 4 copies always. Say due to some reason, if this pod is died, so automatically your replica set controller, it creates one more pod. So the count it will makes 4. So desired state and actual state, it should be always equal to 4, so that your replica set will take care. So that is the reason this replica set also we are telling it's a controller only. It's a Kubernetes controller. So this Kubernetes replica set is controlled by the deployment controller. So this deployment controller is controls this replica sets. So what do you mean by scaling, rolling updates and rollbacks? So when you say the scaling, as the name indicates scaling, say you have the 4 pods here. So 4 pods, you are going to make it 8 pods, and you are deploying, you are executing this YAML file again. So what Kubernetes it will do, instead of 4, it will make the 8 copies. Now 4 copies becomes 8 copies. So replicas, because you mentioned 8. So inside the deployment it will make another 4 copies of the pod. So then your replica set will become 8. So this, when you are converting from 4 to 8 or 8 to 4 or 2 to 4, you are increasing the number of pods inside the deployment. So that we call it as a scaling of your application, scaling up and scaling down. So why do you need the scaling? Say your application users are less in when you hosted your application the first time, so maybe only 100 users or only few users are there. So going forward, due to demand, increasing the demand of your application, maybe users are getting increased. So that time 4 pods may not be sufficient to manage all the requests. So you have to you will be doing, you are increasing the number of pods. So you're increasing 8, 10 or like that. So that's why we're calling it as a scaling up and down based upon the demand. That's nothing but the scaling. So now what is the meaning of the rolling updates? So what is this rolling updates? Rolling updates, say you have the here in the application, if in the YAML file, if you see what is the version of the Docker image you are deploying, point 2. So you may be required due to patches or some enhancement you did in your .NET application. So you made it the image 3. So you don't want to take the point 2 0 0.2 image. Instead you have to deploy 0.3 image. So you will just change the desired state of your YAML file. Is point 2 to point 3 you will update, and you will deploy it to the Kubernetes. So that time what happens, it will change your image inside this container. Your image will be there. So that image version, it will change from point 2 to point 3. So you are rolling the updates, you are deploying the updates to all the pods. So that is nothing but rolling updates. And what is rollbacks? So now you deployed point 3 image to all the pods of your deployment, point 3. So you got to know that there is an issue in the point 3 version of your image. You want to roll back to the point 2 version, right? You want to roll back to the point 2 version of your image inside the deployment. So you will change your YAML file from point 3 to point 2 again. Then you will redeploy. That means you are changing the version from point 3 back to point 3. That's we call it as a rollback. So all these scaling, rolling updates and rollbacks, it is managed by the deployment with the help of ReplicaSet deployment controller and the ReplicaSet controller. So this is the theoretical part. Okay, so whenever you are creating, there is a chance of creation of multiple replica set rather one replica set. So this is one replica set, right? So when we are changing the image, and when you are rolling backs, there is a chance of creation of multiple replica sets. So this is something theoretical part of replica set. We will clearly see practical example, and practically we will see how the replica set works now. Okay, now quickly see any replica set present in the Kubernetes. Okay, so the command we will use is kubectl get rs. Rs is nothing but the replica set. So there is no resources found in the prod namespace. So there is no replica set. So well, let's see any deployments are there. So kubectl get deployments. No resources found. There is no deployments also present in the prod namespace. So prod namespace, there is no deployments and there is no replica sets. So now let us quickly execute our YAML file. This is already I have written here in the previous section only. So there are 3 properties additionally we have added, that is revision history limit, progress deadline seconds, and min ready seconds. So we will see in a great details in a few seconds. Okay, so now replica set I am making it as a 4, so that means 4 pods it will create. So now let us see any pods are available. Get pods. Do we have any pods? No, there is no resources found. There is no pods, no deployments, and no replica sets. Okay, so now I'm not going to create pods manually. I'm not going to create deployments manually. I'm not going to create the replica sets manually. Manually, in the sense, Uh, I'm not creating with the commands, each commands. Okay, so rather I am just creating all the pods and deployments and replica sets via declarative model. The declarative model means with the YAML file. So now, what is the command you will use to deploy your application? So kubectl apply -f deployment dot yaml. Okay, let us execute. Now the deployment is got created. So now let us quickly check kubectl get deployments. So this is a deployment. Now you see there are 4 by 4 and up to date is 4 and available is 0. That means still your pods are getting created and containers are getting created. So now 4 by 4, let us quickly execute the command again. Available still 4. Now we will see what is the um, deployments we have seen. Now kubectl, we will see replica sets rs. So you see now the replica set 4 because in the YAML file we mentioned it is a replicas are 4. So 4 replicas are got created. So inside a replica set, like 4 pods are got created. To see the pods, kubectl get pods. This will show the 4 running pods, right? So now when you see the get deployments again, earlier the available were 0. That means it was taking time to create the pod and containers. That's why it was showing 0. Now the availability of pods are 4. That means 4 pods are available under one replica set. There is only one replica set. As I have explained in the theory part, replica set will be only one. Inside 4 pods are created. So available 4 pods. Okay, so now what we will do is we will just change the image. We will just change the image part from point 2 to point 3 to point 2. Okay, so now we will just change the image. It may be point 3 to 4 or 4 to 5. It's up to you. So now let us redeploy it. So apply deployment.yaml, the configuration got created, right? So now the deployment is succeeded. Now when you see kubectl and get replica sets, you see the now 2 replicas are present, right? So that means why 2 replicas are present, we have changed the image from point 3 to point 2. That's why the old replica set, it will be still available, but that old replica set will not have anything, right? So we are just moving from one replica set to another replica set, right? So to explain you in a better way, I'll just draw the diagram so that we will get the more idea on that. Okay, so now we have one replica set. What we change it from image from point 3 to point 2. So what your Kubernetes will do whenever you are changing the image name. So this is one replica set. Earlier there are 4 images were there in this replica set rs1 image. Rs1 replica set, there are 4 images. So when you change the image from point 3, you change the image from point 3 to point 2. So that means something you updated and you just change it from point 2 to or point 3. Once you change, what will happen? So Kubernetes, it will create a new replica set. So this is replica set 2. This will create a new replica set and all new images point 2, it will just all the new images, it will be recreated in the new replica set. So now this replica set will be empty. So how it will create? First, initially it will just it will create one and it will remove the replica set from here and it will create another replica set, one pod, and it will remove one pod from here in this new replica set, and it will create another new pod and it will remove another pod from the old replica set, and it will create one more. It will remove the pod from here in the old replica set, it will create one, and it will remove from here. So finally, so replica set, how many replica set we mentioned? We mentioned four replica sets. Sorry, not replica set, four replica set count. Replica set four we mentioned. That means it will create in the new replica set, it will create the four pods. So after creation, this old replica set count, it will be empty. So still the old replica set, it will be still available in the Kubernetes cluster. This is a new replica set, it will be available. So why Kubernetes, it will still, it keeps old replica set? Why it, what is the reason behind Kubernetes to keep this old replica set still? That means, again, maybe tomorrow you are rolling back from point 2 to point 3 again. Okay, so that's why what Kubernetes will do, it will still keep, and to in future if you want to roll back the changes again, so it will still use the old replica set, and it will move all the pods from here to here with the new image name which you updated in the YAML file. Okay, we will just see. So that's why you are seeing the two pods. Okay, that's why you are seeing the two replica sets. So this is one replica set and replica set. Now earlier it was current were one, and you are seeing the some mismatches, right? If you see now, it should have been moved all the pods from one replica set to another replica set. See, this is 8677 is the old replica set, and this is the new replica set. This old replica set, it was pointing to the point 3 image, and this is pointing to the point 2 image. So it will take time. So now there are three properties we have defined here. One is revision history limit. So what is this revision history limit? See now, if you see, this is a old replica set, right? Say you are changing from image point 3 to, if you are changing to image point 4 again. So what Kubernetes will do, it will create one more replica set. All these spots will be moved here, right, with the new image point 4 image. So like that, if you are keep on updating the image names in the deployment, because enhancements will be coming always, right? So if you are keep on images, keep on updating the image, so replica sets will be keep on creating with the number of pods. So one point of time, this all replica sets, Kubernetes, it will not delete immediately. So when so one point of time, if it is increasing the count, what you mentioned here, for example 10 replica sets you mentioned. So if the count of the replica set is 11, so the previous one replica set will be deleted. So it will keep the backup of only 10. The latest 10 will be keeping. So Kubernetes will keep only 10 replica sets when you are keep on if you are updating the images. So the now next, what is this progress deadline seconds? Okay, so that means, for example, whenever you are updating the replica sets, okay, or image, right? So new replica set will be created. So all the pods, it should be up and running when you are updating. Say for example, if you are updating from point 2 to point 3, point 2 to point 3. So now let us execute the apply command again. So deploy, yeah, apply f. So meanwhile, I will also take this command. There is a one command to check the status of the deployment, right? So if I take that command quickly, yeah, so here I'll just copy that command. kubectl rollout status deployment demo deployment. I am just checking the status of the deployment. So now kubectl apply. So I have changed it from point 2 image to back to point 3. Okay, so now when I enter this, so it will just configure it. Now quickly I will check the status, right? If you see the rollout status, the demo deployment still not found. Okay. Now, if you see kubectl rollout status deployment, the demo deployment, you see it will give the status. You see rollout to finish, 2 out of 4 new replicas have been updated. So whatever I explained in the here in the theory part. So it will be one by one, all the pods will be recreated in the new replica set. So that's what it is happening. So one by one it will take. So how long it will take? Say for example, one replica set, one pod is changed from old replica set to the new replica set. So how much time it will take? It will take the time which you defined in the YAML file. Say here minimum ready seconds you mentioned, it is a 30 seconds. So once one pod is moved from one replica set to another replica set, it will wait for 30 seconds. So replica must be up and running for 30 seconds. Once it is up and running for 30 seconds, then only it will go for a next pod to move from one replica set to the new replica set. Okay, so what is this progress deadline in second 600 means? So whenever any failure occurs, okay, when for example this image is not found, that time if any failure occurs, so what Kubernetes will do, it will wait for 600 seconds to consider it is completely failed. So I'm telling you, wait for 600 seconds. 600 seconds you wait. So after 600 seconds still the pods are not up and running, then you consider it is a failed deployment. So that is the deadline seconds we are mentioning here. So maximum unavailable, I am just mentioned here. Don't consider any unavailability. Okay, all po- pods inside a replica set should be available. So that's why we are mentioning a zero here. If you mention one, what happens? It will consider one unavailable user in a declarative model. We mentioned unavailability is one. It will create one temporary pod, and it will do the parallel move from pod movement from one replica set to another replica set. That's what we mention zero now. If you mention one, it will be doing the parallel movement. All right, so max search, what is this maximum search? Number of pods that can be created above the desired number of pods during the update. So maximum search, so that means what it will do is one extra how many extra pods can be created when Kubernetes has to create. So that means maximum search it will take all, the maximum can be one. That means one temporary pod can be created. So pod count may be 11. That's why it should not go more than 11. So we are limiting it with a 1. So maximum unavailable, we are telling the pod count may available pod count may be 9. So because maximum unavailable, if you mention 1, it can go to the 9. So now we're mentioning 0, that's why the maximum available is 10. So maximum search it can go 1 extra. So it's like that. So that's what about these new properties information. So these newly created rolling updates and all. So you can also see the whenever you are created applied the status, right? You can use this command kubectl rollout status. It will give the status of the deployment. So once everything is done, it will give the status demo deployment successfully rolled out. So now we mentioned 4, right? So it has taken each pod is taken 30 seconds time to move from one replica set to another replica set. That means to create it. So that means 4 replicas, that means 4 pods we are creating. So 30 means one pod 30 seconds it is taking to up and running. So it is taken 2 minutes of time to update it, so to complete this operation, right? See, manually we have not created any pod. See, once you deploy your YAML file to the Kubernetes, you should be getting kubectl pods also. Get pods. See, 4 pods are running. So even your replica set will take the self-healing. We are talking about the self-healing, right? Say now if I am deleting forcefully these 2 pods inside the replica set, your replica set will take care of recreating of 2 new pods in a fraction of seconds. So it's got deleted. I'm not doing any operation. See, automatically your replica set is created another 2 pods. Even if I am deleting all the pods manually, so your replica set it will create, because we are mentioned in the declarative model, we mentioned it's a 4 replica set, right? So it will immediately fraction of second it will create a new pods in the replica set. Okay, so now coming to the another point is there are 2 options we have. Okay, so whenever you are deploying, you can also deploy it via the command, you can use the command imperative way. Imperative means manually kubectl scale demo deployment. This will scale up. Okay, so you can also, instead of using the YAML file, still you can use the command. Okay, so kubectl scale deploy, I'm telling scale the deployment from 4 to 8. So this will scale up, right? So when you say replica set, I'll just write that command, the copy. What we can do is here, instead of hyphen replica, it's hyphen hyphen. Okay, so now I can change it to 6, from 4 to 6 manually, right? See, it is scaled up. Now if you see, you will be getting 4 pods here, 6 pods. We mentioned 6 pods, right? Takes fraction of seconds time, and it will update it to 6. So the whatever you are doing manually, right? So always it is better to avoid the manual commands. So that is, we can imperative way, always avoid this imperative way, always go with a declarative way. Declarative way is nothing but via YAML manifest file. So why we have to avoid this imperative way updating manually means, if somebody is executing your YAML file again, so whatever the changes manually you did, that will be overridden with the declarative way. So always best approach to go with the declarative way, so that you can also check in your YAML file in your repository. So you will also get the history of your changes in the server. Okay, so when I'm redeploying with the deployment.yaml, your YAML, your file changes will be appeared again. So now the replica sets again 4, which we mentioned in the YAML file. So now when you delete your deployment file, you just use just simple command kubectl delete, and just delete this deployment.yaml. So the deployment name. Okay, so you no need to mention deployment completely, you can also mention only deploy, demo hyphen deployment is my deployment name. So now deployment got created. With this deployment, you also once you delete the deployment, with this you are also deleting the pods, you are also deleting the replica sets, you are also deleting the demo deployment. If you see the get pods, and if you see kubectl get pods, you will not get any pods, because you already removed everything with the deployment. And if you see any replica sets rs, also you will not get any replica sets. Okay, so this is all about the replica sets. Just to brief, replica set is also a controller like deployment controller. Deployment controller, which is deployment controller is manages the um, replica set controller. So replica set controller, which is useful to maintain the count of the pods inside the replica set. So whatever the replica set count you mentioned, so that counts, it will be maintained by the replica set controller, replica controller. So if any pods it will dies inside the replica set, so replica set controller, it will automatically, it will taken care with the help of deployment controller, and it will make your whatever the desired state you mentioned in the YAML file, and with the actual state of the Kubernetes, it will just match. That's all about all the replica set controller in Kubernetes. If you have any questions, feel free to post it in the comment section, and please provide any feedback also. Thank you for watching.